Good morning, everyone. Am I audible?
So,
Okay. Okay. So, coming to our third module. Okay. So, this is your like physical geology, and under the physical geology, we will be studying some of the geological work of the natural agencies. Okay. So, basically, here these rocks, okay, the rocks that you find at the surface of the earth, they are, actually they are subjected to some direct or indirect attacks of a number of natural agencies. Okay, so natural agencies, if I say, so that means they are like atmospheric gases, you can say, heat, you can say, moisture, surface, then wind is there, okay, ice is there. So all these are your atmosphere, these are your natural agencies. So these rocks that are, exposed at the surface of the earth, so they are, subjected to these natural agencies. Okay, then these agencies, actually they are, ceaselessly operating, you can see, at places, at individually also, or at places in close cooperation with one another on the surface rocks. Okay, and that is prevailing from season to season, and you can say year to year. So, they are these rocks, they are, or these natural agencies, these are, responsible for modifying the physical features existing on the surface. Okay, so they, what they do, they modify the physical features of these rocks on the existing on the surface. So now if we take an example of a stream, suppose. Okay, so what does this stream do? So they carry, you can say, they carry away every year, millions of tons of sediments to seas. So they, where they are getting this, load, this enormous load, from where they are getting, so they are getting it from the slopes of their valleys. Okay, and also from the, you can say, from the rocks at the base and sides of your channels. Okay, so if I say in some simple words, is that every year, like millions of tons of materials that makes the mountains, plateaus, or plains and valleys, they are washed away. Okay, so as a result, what is happening, the action of these rivers, they are flowing through them, it is modifying the existing river valleys, and also the other features of, like drainage basins every year. Okay, so again, this the work of these natural agencies, they can be either, destructive also, or they can be either constructive also. So if we have to explain this destructive or constructive nature, okay, so we can take the example of a river. Okay, suppose these rivers, what they do, they carve out the valleys by some eroding rocks. Okay, slowly they carve out the valleys by the eroding rocks from the mountains, you can say. Okay, so these valleys, they are, what they are doing, they are constantly enlarged, and they are depend, by this rivers, okay, in association with some natural agencies. Okay, so this one is an example of a destructive work of rivers. Now if I come to the constructive aspect of the rivers, so you can see that these rivers, they deposit their load, okay, at some places on the land or along, you can say, the seashores, and even at the sea bottoms, they deposit their loads. And as a result of that, what is happening, they are building up, such features they are building, like you can say, like alluvial plains, like flood plains or deltas. So these are, they are building up, so this kind of landforms. So this is a, you can say, constructive aspect of the rivers. Okay, then now we are coming to some of the terminologies that are we are going to discuss in this module. Okay, at every stage you are going to get this terminologies. So first one is your like weathering. So what is weathering? So you can say that this weathering, it is a process of, you can say, decay and disintegration of rocks. Okay, basically weathering, it is the process of decay and disintegration of rocks under the influence of certain physical and chemical agencies of the atmosphere. Okay, so this decayed and this disintegrated product, that they generally remains at or near the parent rock body. Parent rock body, from that means from where these smaller fragments are forming. So they, this smaller, this integrated, disintegrated, or this decayed product of this rock, so they basically generally they stay at or near the parent rock body. Because why? Because the weathering agencies, they do not involve in the removal of these end products to any distances. Okay, so that is your weathering. Weathering is your decay. It is a process where the decay and disintegration of rocks, it is formed under the influence of some certain physical and chemical agencies. Basically, it is the breaking down of rocks and minerals into some smaller fragments. Okay, so that is your weathering. So now coming to the next one, that is your erosion. So erosion, you can say, it is a like it is a broader term. Okay, it is a broader term that signifies the breakdown of rocks of the crust by the natural agencies, obviously, and they are they are characterized with some motion. Motion, if I say, that means motion like wind, you can say, running water, you can say, then moving ice. So basically it is the it is the like these terms are all similar. So erosion, it is also a breaking down of rocks that are in the at the crust of the earth by all these natural agencies, like your wind and water and all these natural agencies. But here the characteristic is that here they are in motion. Okay, motion such as your wind or running water or your moving ice. Okay, but and like with the help of their velocity, okay, these agents, like velocity of this wind or this running water, whatever velocity they have, these agents, they not only gradually disintegrate the rocks, but also they remove the broken particles, or you can say the smaller fragments, to very far off distances. They carry the broken particles or the fragments to very far distances. So that is your erosion. So next is your comes your denudation. So denudation, it is basically it is taken from a Latin word, that is your denudere. It is from a Latin word, and it is known as your to like uncover. Okay, so basically denudation, it is a sum total of the processes of weathering and erosion. So it is a total of the process of weathering, both weathering and erosion. Okay, so a denuded landscape, it is one that has been produced and it is presently exposed as a proof of the collective work of the agencies operating in that area. So if I explain this in terms of an example, suppose a river valley, okay, which is it is presently a very much, it is wider, than its maximum width of the river flowing through it. So you cannot say that it is attributed only due to the erosion work of the river alone. Okay, so it is also due to the process of weathering that is operating on its sides, and also it has, it has contributed this weathering process also, it is contributed in a lot of its widening process. Okay, so that is your denudation. So it is not like it is no, that weathering is working alone or erosion is working alone. It's not like that. It is a sum total. It is a process that, both weathering and erosion, it is happening. So these three terms you will be getting in this chapters. Okay, so these are the terminologies you should know before proceeding to our chapter. Okay, so next is your, like, we have what are the types of rock weathering. Okay, so rock weathering, and that is under the work of atmosphere. Okay, this is the one that we have under the work of geological work of atmosphere. We are having different types of rock weathering. So you this rock weathering, we have the two types, that is your, basically three types you can say. One is your mechanical, that is physical weathering, and the other one is your chemical weathering, and also number three is your biological weathering. Okay, so this mechanical weathering, you can say, what is mechanical or physical weathering? It is, you can say, it is a natural process. Okay, it is a natural process of the disintegration of rocks or into some, like smaller fragments and particles through, some essentially physical processes without a change in their composition. That means, like, here the rocks are, they are disintegrated into smaller fragments and particles, okay, like without changing in their chemical composition, or without any change in their composition, the rocks are, disintegrated into smaller fragments. Okay, only there is a physical change, but there is no change in their composition. So that is your mechanical weathering. So under your mechanical weathering, we have four types of, like, how the mechanical weathering is taking place. But you can say, like, temperature, it is like variation of temperature. It is the, it is responsible for all this mechanical weathering of rocks exposed on the surface. And these whatever, like physical weatherings are going on, there are in there done in two types of two different ways. That is, first one is your cross section, and the other one is your thermal effects, and also your exfoliation and unloading is also there. So, and in chemical weathering also, here chemical weathering, they actually disintegrate and they uh, break down the rock particles, okay, into smaller fragments, and here they change the molecular structure of the rocks and the soil. That means they change the composition of the rock. So here also they are in different processes, like your solution, then hydration and hydrolysis, then oxidation and reduction, carbonation, and your colloid formation. Okay, now coming to the first one of your mechanical web, or that is your physical weathering, that is your frost action. So like this water, they, when they freeze, okay, so they undergo like, there is an increase in its volume by about, you can say, 10%. Okay, so there is, when this water they freezes, so there is an increase in its volume by about 10%, you can say. Okay, so in areas where there is no, there is intensive cold, and it is very humid climate, so what happens, the temperatures, they often, they fall below the freezing point of water. Okay, and during the winter, like winter months, so these temperatures, they often fall below the freezing point of water, and very repeatedly they fall during the winter months. So this, like, process, of freezing of this water, like when it is happening within the pores, okay, it is a, it is a very common observation you can see. So this, like, process of freezing of water, when it is happening within the pores or cracks or fractures, or even of the rocks, they affect them very considerably. Okay, so this, the original, what happens, the original openings of these rocks, they are widened at the very first stage of the attack, and what happens, and after that they accommodate more and more water to, like, introduced into them, okay, and they freeze in some subsequent cycles. Okay, so that is your like it is known as your frost action. It is happening in your frost action. Okay, so now what happens is that when these frost fragments, okay, when these frost fragments that are formed, they can be of angular shape, they can be of subangular shape, or they can be irregular in like irregular shape. So they remain spread over the parent rock, having the very flat or the flat slopes. So if like this original surface forms a significant slope, and it is commonly seen in case of some hilly hills or in some mountainous regions. So these frost sections, they actually gets heaved up. Okay, so you can see a heave type of structure. They get heaved up, and then they finally roll down the slope under the influence of what? Under the influence of gravity. Okay, so finally what happens, these fragments, they gets accumulated at the at the base of these mountainous regions. They gets accumulated there as heaps, and these are commonly known as your scree deposits. Okay, so in the picture one, you can see this is a scree deposit, and this one is a talus slope. So again, talus slope is what? Talus or talus slope. Basically, this when these scree deposits are formed, but in some cases, what is happening is that when the slopes, they are very stabilized, and the gravity there is also very weak. So these fragments, these frost formed fragments, these they remain very like untidily scattered. They remain untidily scattered over the surface of the slopes. So these slopes are known as your talus slopes. Okay, so that is your talus slopes. So next is your like exudation or exudation. So exudation, basically it is a process, it is a very similar process to your frost action. And here what happens, the disintegration of rocks, they takes place due to what? Due to formation of crystals of sodium chloride. Okay, so within the cavities of the rocks, there is a formation of crystals of sodium chloride is happening, and thereby due to that, the the disintegration is happening. Okay, and basically you can see this type of weathering process in near the seashores. Okay, so next is your coming to the second one, that is your thermal effects, and also known as your insolation. Okay, so what happens is that in very arid regions, or desert type of regions, or semi-arid regions, where you can see that summer and the winter temperatures, they differ in a very huge quantity. Okay, so in those kind of regions, these rocks, they undergo the physical disintegration by another phenomenon that is related to your temperature. And also we know that these rocks, like they expand on heating. Okay, they expand when you heat them, and they contract when it cools. Okay, so basically, like in arid and the semi-arid regions, the difference between this day and night temperatures, or the difference between the average temperatures in summers and the winters, okay, so it is quite considerable there. Okay, so that is your such what happens, such repeated variations in temperatures, if it occurs, if it is exposed or it is experienced by a rock, so gradually what happens, the rock will break into some smaller pieces. Okay, especially in the, you can say, in the top layers, because for the due to the development of tensile stresses, developing from this expansion and contraction. So that is your, like, due to the effects of your thermal stress. Now coming to exfoliation. Okay, so there is a term called exfoliation. So what happens in a very thick rock body, or where the the rocks are in a layered form. So there are these the upper layers of these rocks, they gets affected due to these temperature variations. mostly these upper layers of these rocks are affected due to these temperature variations, and as a result what happens, these upper layers, they may peel off. Okay, they may virtually peel off from the underlying rock mass. Okay, so that is, like, it is known as your exfoliation. So, and also what is happening is that in many cases, such as like there is a change is also accompanied by some physical weathering. So you can see this phenomenon, like where that it is peeling off of the curved shells or from rocks. So they are influence of they under the influence of some thermal effects. So that is known as your exfoliation. You can see some peeling off of the these were upper surface of the rock body as it is shown in the picture. Okay, that is known as your exfoliation, and it is happening due to the variation of your temperatures. Okay, so next is your like unloading. So unloading, you can say this is another process of this mechanical weathering. And here what is happening, very large scale development of this fracturing is happening. Okay, in a confined rock mass, it is, attributed to some removal of the overlying rock cover, you can say. So due to, why? Due to some long erosional work of some these natural agencies. So basically, these rock masses, they remain confined from sides. But what happened due to relief of pressure from the above? So they generally expand upwards. Okay, they expand upwards, and consequently what is happening, joints are developed in them parallel to the uncovered surface, and they divide due to the development of these joints. You can see some they are divided into some sheets like structures. So that is your unloading. So basically in unloading, the this surface of the rock, it expands upwards as it is shown in the picture, you can say. Okay, so this is your unloading. So next we come to chemical weathering. So in chemical weathering, already I told you that it is a process of like alteration of these rocks. Okay, by changing the chemical composition of the minerals there. Okay, so basically that is your chemical weathering. So under your chemical weathering, we have your solution, then your hydration and hydrolysis. So first, let us come to solution. So basically, what happens is that some rocks, okay, that contains one mineral or two mineral or more than that minerals. So basically, sometimes they are soluble in pure water. Okay, they are soluble in pure water, but not to a great extent, but to some extent they are soluble. So examples are like, you can say rock salt is there, gypsum is there, then calcite is there. So basically, it is known that this pure water, okay, pure water, it is not a good solvent of minerals. Okay, so but when this pure water you carbonate it, okay, when like addition of this carbon, so when you add carbon to it, so what happened, the water gets carbonated, and due to this carbonation, so its solvent action, like for the minerals, it gets enhanced. And then what happens, the rocks are this carbonated water, it dissolves the rocks very effectively. Okay, like example is your limestone. That limestone, it is not easily soluble in pure water, but when you carbonate the water, the carbonated water will dissolve the rock very effectively. Okay, so that is your solution. Now coming to hydration and hydrolysis. So these two processes, these are, you can say, indicates the direct attack of the atmospheric moisture on the individual minerals of these rocks. Okay, so hydration, basically it is what it is, it is a chemical reaction, you have to say, that involves water that is added to the chemical structure of a mineral. That means here the water is added to the chemical structure of a mineral. Then you can see the example of a like anhydrite is given here, calcium sulfate. Then it is, when water is added to your anhydride, that is calcium sulfate, you get calcium, gypsum you get. Okay, so the chemical formula for gypsum is given here, CaSO4 2H2O. So that is your hydration. And again, hydrolysis, it is the process of exchange of ions from water to the crystal lattice of the mineral. It is called hydrolysis. So again, it is this hydrolysis, it is a very common process that you see in the weathering of a silicate mineral. Okay. So next is your oxidation and reduction. So oxidation, basically it is a process of like addition of oxygen. Okay, addition also and combination of oxygen to the minerals of the rocks. Okay, so that is your oxidation. And the process of removal of oxygen, it is the reverse of oxidation, it is known as your reduction. Okay, and the effects of this oxidation weathering, you can easily observe from the color changes, okay, produced in iron bearing rocks, because here iron is the more important, chief constituent of many minerals and rocks. So here basically you will see the effects of oxidation weathering from the color changes that are produced in the iron bearing rocks. Okay, then comes your carbonation. So carbonation, basically it is a process of weathering of rocks under, you can say, under the combined action of your atmospheric carbon dioxide and your moisture. Okay, so if this atmospheric carbon dioxide and this moisture, they combine together, so they form a reacting acid, which is known as your carbonic acid. Okay, so this acid, when it is formed, it exerts a very corrosive action, okay, over the silicate bearing rocks. Okay, they form a very corrosive action over the silicate bearing rock. So that is your carbonation part. So next is your colloid formation. So colloid formation means, like the process of this hydration or this hydrolysis or this oxidation or this reduction, okay, that are operating on the rocks and minerals. They may sometimes result in splitting of the particles into smaller particles called colloids. So the process, for this hydration, hydrolysis, oxidation, so all these are, leading to the result of splitting the particles of the rock fragments into very smaller particles, that is known as your colloids. Okay, and this formation of these colloidal particles, it is common in where, in the weathering of your clay minerals, that is your silica and your iron oxide. Then one more term is there, that is your spheroidal weathering. And spheroidal weathering, it is a very complex type of weathering that is observed in your jointed rocks, you can say. And also it is characterized. How will you characterize a spheroidal weathering of rock? It is characterized with the, like the breaking of the original rock mass into some spheroidal blocks. That means the rock, it will look like a spheroid. Okay, and this spheroidal weathering, it is due to the action of your mechanical and chemical weathering. Okay, due to this, it is believed that your spheroidal weathering is happening. Okay, so this is your about your geological work of your atmosphere. Now quickly, the same chapter, actually they are divided into many parts. So next is your uh, we are coming to the geological work of your wind. Okay, till then, let me give you the link of attendance in the chat box. Okay, just give me a second. I have given you the link in the chat box. You kindly fill up this link for your attendance. Okay, everyone. Okay, now coming to the next part, that is your geological work of this wheel. Okay, so if I say about the geological work of wind, that means the term atmosphere is coming here and the term air is coming here. So basically, this air atmosphere, everyone knows that it is composed of many gases. Okay, and that gases that are collectively they are known as your air. And if air is in motion, then that is known as your wind. Okay, and this wind, it is it is one of the you know um, uh, you can say a major agent of change on the surface of the earth. Okay, and also this wind, it acts as an agent of erosion also. Okay, that means it acts as a carrier, it acts as a carrier for transporting the particles or the sand grains that are eroded from one place to another. So that is your erosion. We have already discussed about that. And after it carries, or after it gets eroded, or it is carried from one place to another, then it deposits the huge quantities of this of these winds blown these materials. They deposits this material at different places. Okay, so these there are, you can say, three principal modes of activity of where how this wind is doing this erosion or this work, how they are transporting. So there are three principal modes of activity. So that is your erosion, second one is transportation, and the third one is your deposition by wind. So first let us talk about the wind erosion. So wind erosion, basically, the wind, it performs the work of this erosion in three different methods. So number one is your abrasion, number two is your deflation, and number three is your attrition. So what is first your deflation? I will come to first deflation. So like this wind, okay, they actually they possesses they don't possess much of this erosive power over the rocks or over the ground covered with vegetation. But like when this wind, when they are moving with some velocity, okay, when they are moving, they have some sufficient velocity over some dry and loose sands, or also some bare ground that is covered with dust. So it can, what it can do, it can remove, or it can like sweep away very huge quantities of this loosened material from the surface. Okay, so this process of like removal of these particles of this dust and sand by these strong winds that have a very sufficient velocity, so that is known as your deflation. Okay, and this deflation, it is it is the main process of wind erosion in, you can see it in your desert regions. Okay, so that is about your deflation. Now coming to the next one, that is your abrasion. So what is wind abrasion actually? So you can say that wind abrasion, like this wind, it has a powerful like agent of rubbing and abrading the rock. Okay, when it has some load, so it is it is becoming a very powerful agent for rubbing and abrading the rock surfaces when naturally loaded with sand and these dust particles. So this this load, it is acquired by the strong winds and very easily, and when they are blowing over some sand dunes like in the desert. So what is happening, and over the also over the plowed fields also, you can say. So these type of erosion, they are they are involving some rubbing effect or some grinding effect or some they are abrading, or also they are polishing the rock surfaces by all these natural agents like your wind, water, okay, or ice also, with the help of its load as it is passing over the rock. So it is all this rubbing, grinding, or abrading, or this polishing, these type of things are happening, and this is known as your abrasion. Okay, now next is your like final one is your attrition. So the attrition, like when these sand grains or these other particles, they are lifted by these winds from different place, and they are also carried away to some different distances. So during this journey, what is happening, the particles are not moved in, they are not moving in straight lines. Why? They are not moving in straight lines because these particles, they are not of the same weight, and also the wind velocity, they are also varying from from the base to the top of these currents. So these grains, these sand grains, these are moving in some zigzag fashion way, and during this journey they are colliding with some with one another sand grains, again and again they are colliding. So these, due to these repeated collisions, they cause some rubbing due to impacts, and these, due to these, the wear and tear of these load sediments are happening, and that is known as your attrition. Okay. Now coming quickly to the next one, that is your sediment transport. Sediment transport, it is happening like first one is your source of the sediments. So this wind, we know it is an active agent of sediment transport in nature. Okay, if the meeting ends, it is showing like 5 minutes was there. So if the meeting ends, then you please fill up the form and we will continue from here from in the next class. Okay. So I'm quickly trying to finish. So this source of sediments, like this wind, it is an active agent of this sediment transport in nature. We know that, and the materials of this fine particle size, like this clay or silt or sand, they are occurring on the surface of the earth, and they are transported in some huge volumes, okay, from one place to another and in some different regions of the world. So this is a a very great part of this wind load. It is contributed by what? By dry incoherent regions like your sand deserts and your freshly plowed fields. So these are the source of your sediments. So next one is your like the methods of transport, how the wind is transporting the load. So that is done in two ways. That is your suspension, and the other one is your saltation. So this suspension, like the very light density clay and the silt particles, they can be, lifted by the wind from the ground, and they are again, carried high up to the upper layers of this wind, and where these move along with the winds. So these type of sediments which are very light, they move along with the winds, and that is known as your suspension, because these particles, when if they are once they are lifted up, so they are not allowed to rest on the ground again. Okay, so that is your suspension. Next is your saltation. So saltation is it is happening with the heavier and the coarse sediments, such as you can say pebbles, gravels, all those. So they are lifted up periodically, okay, with very high velocity times, okay, during the high velocity wind. So these high velocity this heavier and the coarser sediments, they are lifted up, and they are carried for only very short distances, and that is also very for smaller heights above the ground. So that is this may be while they are carried, they may be dropped, and also they may be picked up again and again during their transport process. So that is known as your saltation process. Okay, then next is your wind deposits. So wind deposits, actually there are, it is done in two ways. Number one is your dunes, and number two is your loess. So these dunes, they are, you can say they are some variously shaped deposits of the sand grade particles. Also they are accumulated by these winds, and these are typical sand dune. Also you can define it as a broadly, it is a conical heap type of sand, okay, that is characterized with you can say it has some